Hello, everyone. I'm Dr. Roopa KP, consultant, Department of Emergency Medicine from Bangalore Baptist Hospital. I'd like to thank SEMI for giving this wonderful opportunity and platform to revise all the basics. I'll be talking about p-value and its significance. Now, we all know that p-value is one of the most widely used statistical terms in biomedical research. It is one of the most commonly used and as well as most commonly misinterpreted or overinterpreted. So let's look at what it is actually. So p-value, what does it mean? We have commonly heard it as p-value less than 0.05. What does that actually mean? Does it mean a 95% chance that the result is real? Or does it mean a large or important effect? Or does it mean that the results it replicates? Or does a p-value of more than 0.05 mean that the null hypothesis is true? So p-value is nothing but probability of observing the data or something more extreme if the null hypothesis were true, or simply in layman terms, whether an observed effect is likely due to chance, whether whatever interpretation that is, or the observations that have been made in your research, has that happened like, due to chance, whether it was just sheer coincidence that has happened. So that's what p-value emphasizes on or sheds some light on. So to understand more, we need to realize that in any kind of research, you kind of hypothesize things. So we have something called as the null hypothesis and an alternative hypothesis. So in the null hypothesis, we need to know that there can be two errors that can happen when we are trying to put it all together. So when the null hypothesis is true and we accept the null hypothesis, or the null hypothesis is false and we reject the null hypothesis, those two are the correct decisions that we generally make. Okay, but then there are two types of errors that come out of it, that is type 1 or the alpha error and type 2 error or the beta. So type 1 error is when the null hypothesis is true and we reject it, and type 2 error is when the null hypothesis is false and we accept it. So just to give a better example, I mean, just to get the context of it, we're looking at someone who has to be proven innocent or guilty. This is in legal terms. And when we look at the null hypothesis, when actually the person is innocent, and then the person is, even with the research finding, the person is found to be innocent and set free, that's a correct decision that is made. Similarly, when the person is actually guilty and the person is found to be guilty by research findings, then the person is jailed, and that's a correct decision that is made. Now come to the two errors that we were talking about earlier. So we're looking at type 1 error or the alpha error, where the person is actually innocent and he or she is found guilty in the research and has been jailed because, according to the investigation, the person is guilty. Okay, that is a type 1 error or an alpha error. Whereas type 2 error is where the person is actually guilty, but according to the investigation, he or she is found to be innocent and set free. So that is the type 2 error or beta error. Now, amongst these two errors, we want to minimize alpha error as much as possible. That is basically, jailing someone who's innocent. We don't want to do that. Okay, we would rather, it's okay to set free someone who's guilty rather than jailing someone who is innocent. So we always look at reducing the type 1 error or the probability of type 1 error happening. That is nothing but the alpha. So let's look at the steps that is involved up till the p-value and how we interpret it. So the first thing is, obviously we need to specify the null and the alternative hypothesis. Then we say the significance level, that is nothing but the alpha, that is nothing but the probability of type 1 error. So this is an arbitrary number. So usually it is a 5% or 3% or 1% corresponding to 0.05, 0.03 or 0.01. The next thing is to calculate p-value using various tests. Now, depending on the data set that you have, you might use a t-test or a z-test or an f-test or a chi-square test, and then you will calculate the p-value. Then we compare the p-value to the set alpha. So let's break it down with an example, which makes more sense for us right now. So we have a drug X which has been or which you want to investigate and see whether it is lowering the BP more than a placebo. So our null hypothesis is placebo and drug X are equal. Okay, so placebo, the effect of placebo is equal to the drug. Whereas the alternative hypothesis is the effect of the placebo is not equal to the effect of the drug X. So our study design, let's assume that there were 300 patients who were enrolled with who were hypertensive. 150 of them received drug X and 150 received placebo. And then we rechecked the BP after 8 weeks, and then we looked at the drop in systolic blood pressure. So the results is in case of the group with the drug X, where drug X was used, the drop was 15 mmHg, whereas with the placebo, it was 8 mmHg. The difference is 7 mmHg. So the alpha was set at 5%, or that is 0.05. And using t-test as a statistical test, the p-value was found to be 0.03. Now, when this is this is what comes up as our final statistical inference. How do we interpret it further? So interpretation of this p-value of 0.03, that basically means if the drug had no effect, the chance of observing a difference as large as 7 mmHg or larger due to random variation alone is 3%. Or simply put, if the drug really had no effect, means that is the null hypothesis that we are looking at. If the null hypothesis were true, the chance of observing such a big difference of 7 mmHg is due to random variation or just by coincidence or by chance itself is just 3%. So it's a very minimum, this one. So when since this 0.03 or the p-value is 0.03 is lesser than the set alpha, that is 0.05, this is statistically significant. So we understood till here that it is statistically significant and what this 3% actually means. How does it clinically translate? So the clinical translation or interpretation is the difference is unlikely to be due to chance. Okay, it provides evidence that the drug X truly lowers the blood pressure more than the placebo. So with that, we should also understand what it does not mean, which is more important, or that's where the confusion happens. Now, this p less than 0.03 does not mean that there is a 3% probability that the null hypothesis is true, or 97% chance that the drug works, or that the effect is clinically meaningful on its own. Okay, so it's not a guarantee of replication. So what we need to say is it can be statistically significant. Whether it's clinically significant, it requires further investigation, further kind of tests and other parameters that we need to look into. So what are the limitations of p-value? It is dependent on sample size. Now, a larger sample size, as the sample size increases, it can yield very low p-values just with the sheer increase in the sample size. And these low p-values can be there for even clinically irrelevant effects. So as is shown in this graph, you can see from a sample size of 200 to 400, the p-value is drastically fallen. So this is just a theoretical, representation of how it can fall with the increase in the sample size. So you cannot just go about or just look at p-value alone and then come to a conclusion. Okay, so we need to do further things or further parameters, consider further parameters when we have to analyze or interpret a p-value. So coming to my conclusion, what does it actually mean? A statistically significant p-value, for example, less than 0.05, suggests that the observed effect, whatever you've observed, is unlikely due to chance. Okay, so this may warrant clinical consideration of further research. So you might need to look into the confidence interval. You might need to do other kind of tests to say this is clinically relevant. This is clinically significant for me to consider or go about it. What it does not mean, again, repeating the same thing, but it's very important for us to know that it does not mean it measures clinical importance. It does not prove causation. It does not provide the probability that the hypothesis is true. Okay, so my take home message is going to be simple. So p values always assume that the null is true, and it's only to find out whether it is, whatever the observed effect has happened by chance or not. And statistical significance does not imply practical importance or clinical significance. Always interpret p-value with context and effect size. Thank you for listening patiently. Have a good day.